Okay, so in general, when you are looking at logarithmic functions, you have the log of x to a base of b, and the solution or the answer that you get in a logarithm, it represents the exponent. Okay, so this represents the exponent to which b needs to be applied to get an answer of x. Okay, so just to remind you, b to exponent y will give you an answer of x. Okay, there's a special case when you're looking at logarithms where the answer that you have is written with the same base as the base of your logarithm. So for example, if you have something like log base 3 of 3 to the exponent 4, well, in this case, the answer will also be 4. If you're trying to write 3 to some exponent to get 3 to exponent 4, the exponent that you need is an exponent of 4. Okay, so let's take a look at that again. So if you're trying to find the answer in this case, what you're actually thinking about is 3 to some exponent will give you an answer of 3 to exponent 4. That's our answer part. That's the base. And what we're trying to solve for is the exponent. And in this case, the exponent is the same as the exponent that's here, an exponent of 4. So your logarithm is equal to 4. And what we're going to try to do in example 5 and in example 6 is try to figure out what the exponent would be that would make this statement true. And in this case, it was pretty straightforward. Okay, we will be looking at examples where you might have log base 5 of 25. And so ideally what you want to do is write the answer part as the same base as the base of the logarithm. So I would rewrite 25 with a base of 5 instead of a base of 25. Okay, we'll talk about that in a few minutes. Okay, so in the special case, the base of the logarithm is the same as the base of the answer. Okay, there's a couple of things that we haven't discussed yet that I want to point out to you. If the base is not specified in the logarithm, it is assumed to be a base of 10. This is known as the common logarithm. So if you see something like log of 100, you'll notice that the base here is not specified. That base is assumed to be a base of 10. Okay? If it is specified, you will see a number like 5 or a number like 3. Okay? If it's not specified, then it's automatically a base of 10, and it's known as the common logarithm. The other thing that I had mentioned a couple of times to you is that the logarithm function is only defined when b is greater than 0 and when b cannot equal 1. Okay, think about why these restrictions exist, and it's related to why these same restrictions existed for an exponential function. So I'm going to let you think about that, that part. So let's look at our next example. So example 5. So it asks us to evaluate each logarithm, and so we're looking at the log base 5 of 25. Now the problem here is that I can't actually use my calculator to evaluate this, and that's because the calculator only knows the common logarithm. So let's say I try to find the log of 25. I get an answer of 1.3979, etc., etc. Now what this actually means is, to get an answer of 25, I would need to apply this exponent, the answer that I have here on the calculator, on a base of 10. I don't have a base of 10 in this case. I actually have a base of 5. So I can't evaluate this question on the calculator. Instead, what I can do is write it as a special case, where I